Hi guys, today we're going to discuss Fluid Mechanics Chapter 3 Fluid Kinematics Quick Tips and Solved Problems. I hope this video is very much useful those who are preparing for competitive exams. So before going to the presentation, please subscribe our channel and like and share to your friends. Motion of the fluid's description. So the motion of the fluid can be described by Lagrangian and Eulerian methods. Next, types of fluid. The types of fluid generally classified in two types. First, fluid properties. Next one, properties of flow. So first, fluid properties: ideal and real fluid, compressible and incompressible flow. And properties of flow: laminar and turbulent flow, steady and unsteady flow, uniform and non-uniform flow, rotational and irrotational flow, one-dimensional, two-dimensional and three-dimensional. So first, ideal and real flow. See, ideal flow, it is an imaginary flow, that means hypothetical, whereas in real flow it is imply friction effect. Next, compressible and incompressible flow. The incompressible flow assume that the flow have constant density, while in compressible fluid flow density is variable and become function of the temperature and pressure. Next, laminar and turbulent flow. The laminar flow, the particle move in a layer sliding smoothly over the adjacent layer, whereas in turbulent flow the particle have random and erratic movement intermixing the adjacent layer. Steady and unsteady flow. First, steady flow. It is the flow in which condition of flow remain constant with respect to time at a particular section, but the condition may be different at different section. The flow condition: velocity, pressure, density, cross section, etc. is etc. Example: a constant discharge through a pipe. Whereas in unsteady flow, which condition of flow change with respect to time. The variable discharge. Uniform and non-uniform flow. Uniform flow, the velocity at a given time does not change with respect to space. Non-uniform flow, the velocity at a given time change with respect to space. Example: constant discharge through variable diameter pipe. Rotation and irrotational flow. Rotational flow, the fluid particle flowing along the streamline rotate about their own axis is called rotational flow, whereas an irrotational flow does not rotate about their own axis. Streamline is a curve that is everywhere tangent to the instantaneous local velocity vector. The streamline is tracing the motion of different fluid particle during its motion. The characteristics of streamline: the streamline cannot cross each others. Next one, the streamline cannot be folding line. Next one, streamline cluster density reflect the magnitude of velocity. Next one, path line. A path line is the actual path of traveled by an individual fluid particle over some period of time. Next one, streak line. Streak line is the locus of a fluid particle that have passed sequentially through a prescribed point in a flow. Next, total acceleration is defined by the total acceleration is local acceleration plus convective acceleration is called total acceleration. Next, stream function. So it is a scalar function and it is two-dimensional function. So stream function denoted by psi. The properties of stream function: it is possible case of fluid flow which may be rotational or irrotational if the stream function satisfies the Laplace equations. So stream function is equal to u equal to dou psi by dou y, v is equal to minus dou psi by dou y. Next, velocity potential function. The velocity potential function is a three-dimensional function. It is represented by the pi. The velocity potential functions exist only irrotational flow, whereas in stream function, previously we discussed, stream function can exist both rotation and irrotational flow, whereas in case of potential function, velocity potential function exists only irrotational flow of an ideal fluid. So here we are going to discuss some key points. First, the slope of streamline m psi is equal to v divided by u, and slope of velocity potential function that is equal to minus u by v. The orthogonal line is nothing the product of the slope of streamline and slope of velocity potential line, so that is equal to minus 1. Now next, the equipotential line is it is called the curve joins same velocity potential. Next, flow is irrotational and steady. It is called potential flow. Next we are going to discuss some few problems. The stream function for a two-dimensional flow psi is equal to 2xy. The velocity at 2, 2 point is, no, you know the formula, that means equation for u equal to minus dou psi by dou y. So substitute u equal to, you will get minus 2x. Similarly v equal to 2y. Now substitute resultant velocity v equal to root of u square plus v square. So you will get 4 into root 2 unit for velocity at 2, 2 point. Next problem, the stream function psi is equal to 3x square minus y cube. What is the magnitude of velocity at point 2, 2? So same, differentiate with respect to x and differentiate with respect to y. You will get u and v. Substitute resultant velocity u equal to u square plus v square. You will get velocity equal to 17 unit. Thank you guys. I think this video is very useful. So please subscribe and share to your friends.